Hello, here's a video about probability. I hope it's of help. Probability, a couple of bullet points first. Always write probability as a fraction, or as a decimal, or as a percentage. And there's two little bits in brackets after that. First of all, it's usually easiest to write probability as a fraction, as we'll see in a moment in the examples that we work through. And the second sort of little sub-point is stay away from ratio. It actually, between you and me, is possible to write probability as a ratio, but it's not a good idea, and it's a way in which people often get confused. Stay away from it. It's not necessary, and it's not helpful. In green, P for probability. Probability. What is probability? Another word for probability, likelihood, possibly. I suppose how probable something is how likely it is. In math, the probability of something happening is the number of ways in which one outcome is possible divided by the number of ways in which any outcome is possible. If that doesn't make sense to you right now, don't worry, because we're going to go through some examples now of common ways in which probability can be tested, or questions about probability can be asked, and you'll understand, hopefully, as we work through these examples, what I mean by that. Let's look at the next page. 1, 2, 3, 4, 5, and 6 are the numbers you can get if you throw a normal six-sided dice, aren't they? So if I throw a dice, I could get any one of those 6 possible outcomes, couldn't you? Those are my different outcomes from throwing a six-sided dice. There are 6 of them. If I asked you what the probability is of throwing a 3 with a six-sided dice, what you would say to yourself is, how many different ways are there of throwing a 3 with a six-sided dice? The answer, of course, is there's only one way. There it is, right there. So there's one way. Let's go back to our grouping at the bottom. There's one way in which throwing a 3 is possible. That's the number on top, if we write it as a fraction. And we can divide that by the number of ways any outcome is possible. And how many different outcomes are possible with a six-sided dice? Well, there are 6 different outcomes, aren't there? 1, 2, 3, 4, 5, 6 different numbers. So how many ways, what's the probability of throwing a 3? 1 out of 6. One chance out of 6, which we write as a fraction as 1/6. Now, if you feel like trying to convert 1/6 into a decimal or into percentage, then you go ahead and waste your time doing that. But the rest of us will carry on, because we've just realised that we can write the probability of throwing a 3 as a simple fraction. It is 1/6, because there is one chance in 6 of it happening. Let's ask some more questions about throwing a dice. How about if I asked you what the probability was of throwing an even number? Well, how many different even numbers are there? 1, 2, 3. There we go. 2, 4, and 6 are even numbers. There's 3 chances of throwing an even number out of 6 in total, which is 3/6. You can simplify that, can't you, being a good boy, to 1/2. So what's the probability of throwing an even number on a normal 6-sided dice? The probability is 1/2, isn't it? Here's another question that you might be asked, or here's another question I'm asking you. Here's another question you are being asked. Never mind, might be. What's the probability of throwing a number that is prime? With a 6-sided dice. Well, which of these numbers are prime numbers? Is 1 a prime number? Hopefully, no, it's not, although you could argue that it is. It just isn't. 2 is a prime number, isn't it? It's the only even prime number. 3 is a prime number. 5 is a prime number. I reckon there's 3 of them again. So the probability of throwing a prime number with a normal 6-sided dice is, again, 3 out of 6, or 1/2. One more question on this while we're on it. How about, what's the probability of throwing... Oh, I don't know, a number that is less than 5. A number that is less than 5. Which of these numbers are less than 5? 1, 2, 3, and 4. These are all less than 5. Is 5 less than 5? No, 5 is equal to 5. And that's not the same as being less than it, is it? So how many numbers are less than 5? 4. How many numbers altogether could I throw? 6. So the probability of throwing a number less than 5 is 4/6. Or I could simplify that, couldn't I, to 2/3. There we go. There's the example probability using 1 6-sided dice. It's possible you could be asked questions to do with throwing 2 6-sided dice, or involving 2 separate objects. And here you can see I've got a red dice at the top with numbers 1, 2, 3, 4, 5, and 6. And I've got a green dice here with numbers 1, 2, 3, 4, 5, and 6. And in black, I've started writing, and I'll finish it with you here, I've started writing what you get when you add the 2 numbers together. With a green 1 and a red 1, 1 and 1 is 2. With a green 1 and a red 2, I get 3. With a green 1 and a red 3, I get 4. And so on. So let's go down to the 5s row on the greens. The 5s row here, 5 plus a red 1 is 6, 5 plus 2 is 7, 5 plus 3 is 8, 9. You can see how this works. Actually, you should see a pattern in the numbers. We start with 1 bigger each time. Let's keep getting 1 bigger. So in the next row, 6 plus 1 is 7, 6 plus 2 is 8, plus 3, plus 4, plus 5, and plus 6. And there we have, in black, all the different possible totals we could get when we throw 2 separate dice, you'll see that not all of the outcomes are different. For example, we see here and here that there are two different ways in which you can make 3. You can throw a 2 on the green dice and 1 on the red dice. Or you could throw 2 on the red dice and 1 on the green dice. Here we see a number of ways of making 8. A green 6 and a red 2 at the bottom, a red 6 and a green 2 at the top. In between you could have a red 4 and a green 4, or a 5 and a 3 on each dice. So we see here there are 5 different ways of making 8. You might be asked a question like, what is the probability, throwing 2 fair 6-sided dice, what is the probability of throwing an 8? In which case you would have to look at this chart, you would have to find all the different ways of making 8, and I've circled them here, haven't I? 1, 2, 3, 4, 5. And there are 5 ways, remember from our original page, there are 5 ways in which the outcome we want is possible, and we now put that over the total number of ways in which any outcome is possible. And I reckon there's 1, 2, 3, 4, 5, 6 numbers on each row in black, and 6 rows of them, and I think 6 sixes are 36. So I reckon the probability of throwing an 8 is 5 out of 36, which we shall write as 5/36. Would you agree with that? Good. How about the probability of throwing... How about the probability of throwing a prime number this time? Let's find the prime number totals. 2, 3, 3. Is 4 prime? No, of course that's divided by 2, isn't it? 5 is prime, isn't it? It's 4 of those. Is 6 prime? No, it's even again. Is 7 prime? Yeah. Lots of these, aren't there? Is 8 prime? No, it's even. Is 9 prime? No, well done. It's divisible by 3, isn't it? 10's even. 11's a prime number, isn't it? And there we go. So how many red circles have I got there? From the 2's, 1, 2, 3, 4, 5, 6, 7. And the 7's make 8, 9, 10, 11, 12, 13. And 2 11's make 15. So we've got 15 out of 36 chances of throwing a prime number. I could simplify that by dividing by 3, I suppose, which would be 5/9. And there we go. The probability of throwing a prime number is 15 chances out of 36, which is 5/9. While we got that up there, by the way, that's why you should always bet on 7 if you've got to choose any number with a 2-sided dice, because it's got the most chances of coming up. That's why you get more 7s on the whole than any other number when you throw those 2 dice, because it's the most different. So it has the highest number of different ways of making it. That's by the by. There we go. So that's throwing 2 separate dice, and that's another sort of way in which you can be tested. If you're given 2 separate things that happen, and you want to, as in 2 different dice, this is one way you can set it out to establish how many total different possibilities there are. Here's another question. Here's the word mathematics. Mathematics. I've written the numbers 1 to 11 above that to show you that there are 11 letters, in the word mathematics. If I asked you what the probability, if I put all those letters into a hat, for example, what's the probability of throwing, of pulling out the letter A, let's say? Well then, if there are 11 letters, my probability is going to be a fraction over 11, out of 11. How many A's are there? 1, 2. So if I put 11, those 11 letters in the hat, the chances of pulling an A out will be 2 in 11, or 2 out of 11, or 2 11ths. What will be the probability of picking out a consonant? How about picking out a consonant? How many consonants are there in the hat? 1, 2, 3, 4, 5, 6, 7. So the probability of picking a consonant would be 7 11ths. Here's a small extension that we haven't talked about yet, and I suppose it's quite possible that you might be asked a question about this. You might be asked to establish 2 different probabilities, one after the other. So, for example, they might ask you the probability of pulling an M out of the hat, and your answer to that would be, well, at part A, 2 11ths. Now, let's say that you've taken one of those M's out of the hat, and you're then asked, what's the probability of picking out the letter A? And here we go. We still have 2 A's, don't we? So our answer is going to be 2, but it's not going to be 2 over 11, isn't it? Because we've already picked an M out of the hat and not put it back. This time, how many letters are there that remain? That's right, there are only 10s. The probability of pulling an A out of the hat now is not 2/11ths, it's 2/10ths. There are 2 chances in 10. You could simplify that, of course, to 1/5. So be aware that um, as you remove the number of different possible outcomes, then your probability of, with the remaining letters or numbers or whatever it might be that you've got in your hat or that you're dealing with, the probability of those will change because the total number of possible outcomes will change as well. Let's say you picked out both of those A's and were then asked what was the probability of pulling out a consonant from the remaining letters. Let's do this in blue. Let's underline the remaining consonants first. 1, 2, 3, 4, 5, 6. There are 6 consonants remaining. Out of how many letters altogether? 1, 2, 3, 4, 5, 6, 7, 8. So out of the remaining 8 letters, 6 of them are consonants. So the chances of pulling out a consonant at that stage would be 3/4. Okay. So as a letter is removed from the hat, so the number of possible outcomes that remain reduces. I hope that's clear. Listen, that's just an introduction to probability. Just to go back to the beginning, write it as a fraction, a decimal, percentage. As you can see there, it's almost always the easiest to write it as a fraction, where the numerator is the number of ways in which you could make whatever it is you want to make, and the denominator is the total number of possible outcomes. That's usually the easiest way. Stay away from ratio. I haven't even talked about it. Don't bother. Just don't. Okay. We looked at the probabilities with a single dice. We looked at the probability with a double dice, and with 2 dice rather, including drawing up the table of possible outcomes so you could work out how many there were, and so you could make sure that you didn't miss any possibilities. And finally, we talked about what happens when the number of total possibilities reduces, so that your probability will change. So the fraction of the probability will also change. There we go. A simple introduction to probability. Hope that helps.